This video discusses the scientific method covered in Chapter 7. The scientific method starts with a theory based on sound scientific principles. We then formulate hypotheses we wish to examine. We then take a sample of data and test our hypothesis, and then generalize back to the population. So step 1, we develop a theory. Step 2, establish a hypothesis of interest. We then take a sample of observations either through a survey or experimentation. We then use statistical inference to test our hypotheses and generalize to the population. Here is an example. Suppose we think that social science students have a higher IQ than university students in general. Then we need to sample social science majors and measure their IQ scores. We cover the analysis of data here. However, there is a vast literature for research methods where you cover the use of standard instruments such as IQ tests. There is an art to creating questionnaires. That we leave to another text. We wish to test if social science majors have a higher IQ score than university students. We use the null hypothesis significance test, NHST. First, we create a null and alternate hypothesis. A null hypothesis is the mean IQ score of social science majors is the same as the mean IQ scores of university students. The alternate hypothesis is the mean IQ score of social science majors is higher than the mean IQ scores of university students. We know from prior knowledge that the mean score of university students is mu equal to 100 with a standard deviation of sigma equal to 15. We now denote the population mean for the social science students as mu subscript a. The A represents the alternate hypothesis value for the mean. We then write the hypothesis as the null hypothesis H0 U sub A equal to 100 versus the alternate hypothesis H sub A U sub A is greater than 100. The null hypothesis is written as a statement we are trying to prove false. So we assume the mean IQ is 100 for social science students and then test to see if this hypothesis is consistent with our data. We then conduct our study and collect observations. We sample n equal to 162 social science majors and find the mean is 102, which is higher than the null hypothesis of 100. So x bar is 102. This value is higher than 100 but could occur just by chance from sampling error. We now have to determine if a sample mean of 102 is significantly higher than 100, or that it could be higher just by chance. We calculate the probability that we observe a sample mean as high as 102, given that the population mean is 100 and the standard deviation is 15. If the probability is low, then we would conclude that the null hypothesis that the mean IQ of social science students is 100 is unlikely. Our cutoff point for determining what is meant by low is called the significance level, or alpha. We typically set alpha equal to 0.05 or 5%. So if the probability of observing a sample mean as high as 102 is less than 0.05, then we would reject the null hypothesis that the population mean is 100. Usual values for the significance level are 5% and 1%. If the alternate hypothesis is that the mean is greater than 100, then we would look at a rejection region of large values of the sample mean. If the alternate hypothesis was that social science students had a lower mean score than university students, then we would reject the null hypothesis for low values of x bar. If the alternate hypothesis is that social science students have a mean score that is different from 100, then we would reject the null hypothesis for extreme values both on the left and on the right side of the curve. We will look at a variety of situations for tests of hypothesis in the following chapters. To review, there are 5 steps in hypothesis testing. 1. Define null and alternate hypotheses. 2. Define the sampling distribution and critical values. 3. Calculate the test statistic using the sample values. 4. Make a decision regarding the hypothesis. And 5. Interpret the results and state conclusions. Thank you for watching. In the next video tutorial we cover estimation of a population mean.